Refraction of light. When a ray of light is traveling in one transparent medium, enters another different transparent medium, its direction is suddenly changed as a surface separating the two media. This change in the direction of the light ray is known as refraction of light. Now let's see the following video about refraction of light. Now here, light is incident on the surface. In a homogeneous or the same material, it is just reflected. This is known as reflection. And in the case of this one, it is just incident and transmitted. You see, it is incident and transmitted. And in some part, it will be just entered and absorbed here. You see, reflection, transmission, and absorption can be just observed here. In an opaque object, reflects most of the light. In transparent, transmits most of the light. Now you can see here, this is just a reflection on a mirror. You see here, transmission is just, this is glass surface, and then refraction of light. The bending of light when it travels from one medium to another medium, or change in direction. Light ray is just incident. This angle is known as angle of incidence, and this one is known as angle of refraction. This is incident ray, and this is refracted ray. This is a glass slab. Light ray is just incident here, obliquely, not perpendicularly. Oblique means slant. Neither parallel nor perpendicular. If it is just perpendicular, no refraction can be just observed. Here you see, refraction just takes place. Air to glass. This is a separating surface. This is how refraction of light should be just observed here at this point. Incident medium and refracted medium. You see, again, outside to the air, it will just be just refracted again. But don't forget, here is the angle of incidence, and here this angle are just equal. This refracted angle is equals to this one also. You see here. You see, this is known as normal. Angle of incidence, angle made by incident ray and with the normal. Angle of refraction, angle made by refracted ray and with the normal. Fermat's least time principle. The path taken by a ray of light between any 2 points in a medium is always the path that takes the least time. This principle leads to the law of the rectilinear propagation of light and the laws of reflection and refraction. It obeys both of them. Now let's see the Fermat's least time principle using this video. You see, light ray is just incident. This is the least time, as it just goes to be, either it follows this one or this one and this one. There is a least time. That least time which should be just observed is known as the Fermat's least time principle. It obeys that one. You see, AK, B, AO, B, and so forth. Light incident in the case of refraction from A, B prime to B. You see here. The laws of refraction are stated as follows. The incident ray, the normal at the point of incidence, and the refracted ray lie in the same plane. Number 2. Light bends towards the normal in denser medium and bends away from the normal in lighter medium. The laws of refraction. What happens when the light is incident on the surface of a transparent medium? You see, this is the incident ray. This is a reflected ray. Absorbed, reflects, and refracts. Laws of reflection. Let's revise here. Laws of reflection. The angle of incidence equals to the angle of reflection. The first one. Incident ray, reflected ray, and the normal all lie in the same plane. This is just the law of reflection. What about the law of refraction? It is just refraction is changing direction as it passes through across the boundary separating two media caused by change in speed. This is optically rather away from the normal. You see, if it is just perpendicular, no change in direction. The second law of reflection, incident ray, reflected ray, and the normal all lie in the same plane. This is optically denser medium, so it bends towards the normal. The incident ray, refracted ray, and the normal at the point of incidence all lie in the same plane. Let's see the following questions here. As the angle of incidence of a ray of light on water surface increases, the angle of the reflected ray, A, also increases, B stays the same, C decreases, will be half of the angle of incidence. This is just now not refraction, it is just reflection. Answer is A. Since the angle of incidence equals to the angle of reflection, from the law of reflection, as the angle of incidence increases, the angle of reflection increases. Fermat's principle of light states that A follows paths of having longer time to complete any 2 points. B follows a path of having less time to complete any 2 points. C travels at a speed of 3 times 10 to the power of 8 meters per second in vacuum. D travels at a speed of 2 times 10 to the power of meter per second in water. The answer is B. Fermat's least time principle is the path taken by a ray of light between any 2 points in a medium is always the path that takes the least time. This principle leads to the law of rectilinear propagation of light and the law of reflection and refraction. (6.6) Lenses. Types of lenses. There are 2 types of lenses. These are number 1, convex lens, number 2, concave lens.